everyone. So today we're going to hopefully briefly look at how we can use code to control a circuit. So I'm going to assume that you have some understanding of really basic coding, maybe with programs like Scratch using blocks and a little bit of text coding as well. But we'll really step through it bit by bit, so it should be fine, no matter what background you have. So first of all, we need to think about how on earth it's possible to get some code, some text that you type or some blocks that you drag around, to control a real physical circuit in the real world. And the way we do that is we use these things called microcontrollers. Some people get microprocessors and microcontrollers mixed up, so I'll explain what they are. Microprocessor is like a little chip like this, and it basically is the brain of a little computer that you can connect a circuit to. So you see, if you see all these holes over here, these are places you can connect wires to, and they can be connected to this microprocessor, and the microprocessor can tell it what to do. But of course, computers are not just processors, they also have memory and other things. So a microcontroller is the full the connection basically between your code and the circuit. So that includes the microprocessor and all of the memory and everything else that it needs. So an Arduino, which is what we've got on the right, is an example of that. It's got a microprocessor on it, and you can connect wires into these black holes over here, and you can put code into it by connecting it to the computer. Here's the USB connection place. So you connect it to the computer, write some code on the computer, and then this code is stored on the Arduino, and then you can disconnect it, connect your circuit to it, and hopefully if you've done the right things with your coding, then it will work. You'll do what you want it to do. Alright, so let's look at, firstly I want to show you an example of what I mean by this. So TinkerCad is the program that we'll be using. If you want to get started with TinkerCAD, you need to make an account. Go to circuits over here, and then you can click create new circuit, but I've got some circuits here already. This is one of them. And so, okay. So on the left, I've got an LED once it loads, or a light emitting diode. Emitting means light comes out of it. So hopefully, if I press start simulation, light will come out of the LED. And it does. Excellent. That is actually a relief. Alright, so you can see it's flashing on and off. Now, if you just connected that LED to a battery, it wouldn't be flashing. It would just be on. And then when you disconnect it, it will be off. So there's something special going on with this Arduino that is making it turn on, then turn off, then turn on, then turn off. So let's look. We can click at on the code button, and I've got it on text. When you start this for the first time, it'll be on blocks, and you'll have these blocks here. Now, you can see, let's just start off with the blocks, and then I'll explain why I don't really like them. Set built-in LED to high means turn it on. Wait 1 second means leave it on for 1 second. Set built-in LED to low means turn it off. Wait 1 second means leave it off for 1 second. But if I click start simulation, it doesn't just do this, then this. It does it again. It goes back to the start and does it again. And it does it over and over again. And so why can't we see this in the blocks? The reason is because some parts of the code are invisible. So we'll click stop simulation, and I want to go to text, which will show us more information. So in the text section, you can see that there's this word loop. And if you've done any coding at all, you'll know that loop well, I mean, even if you haven't, you could probably guess loop means do this thing over and over and over again. So already we're getting some information here that will help us understand what's happening. So really, you're meant to put all your code in here. Now we're going to go through what that text code actually means. But the first thing we have to know is that void setup, there's a setup section at the start, which is setting up the code, and also the things that connect to the Arduino, you have to make sure you're setting them up properly. And again, that's not in the block code, that's in the text code. So we really need to know how to set it up if we want to control it properly. And then void loop. This section contains the things you want the Arduino to do, and it also does them over and over again. Okay. We've done that. Oh, we'll skip that. All right. So here I want to explain the different sections of void setup and void loop, what's inside of them now. You can see we've got a LED here and a resistor here. The resistor is just to slow down the current so that the LED doesn't get too much current through it, too many electrons rushing through all at once and break. So it won't break with this resistor. I mean, we've got pretty low current coming out of here anyway, so it should be fine, but it's good to always put a resistor there. Anyway, this one side of the circuit, this is basically a full circuit. So the wire connects to the resistor, that connects to the LED, that connects back down here. And in between these 2 points, it's actually connected in the Arduino if we code it right. So what's happening is we have to tell pin 13, which is this one, to be an output. So it can either measure something, which we don't want to do. We don't want to measure anything. We just want to turn the LED on and off. Or we can get it to supply our voltage, which is like what a battery does. So this is like doing what a battery does. And then we've got GND, which means ground. So what in practice, what happens is this 13 is like the positive side of a battery, and this GND is like the negative side of a battery. So this is basically, when we code it right, it's pushing all the electrons through the circuit like a battery would. Except, I've told you about the loop, except that it's not on all the time. Pin 13 is not on all the time. It's only on when we write high, the word high. Digital write is, we use that because this is a type of, the black holes that you put things into are called pins, and it's a digital pin, which can only be high or low. So this digital number 13, we can either turn it on or off. So this time we're turning it on by using this function, digital write function. What a function is, it's basically a word that's a shortcut for something you want to do. And then in the brackets we've got 13, which is telling the Arduino, because the Arduino doesn't really know which pin you're talking about, but you have to tell it you're really talking about pin 13. That's the one you want to turn on. And then high is the second part over here. Digital write, you need to put which pin it is and whether it's on or off. So we turn it on. And then we turn it off a little bit later. And then in between, we've got this delay function here, which means don't change anything for a certain number of milliseconds. So if we turn it on, delay 1000 means we wait for 1000 milliseconds, which is 1 second. And then we turn it off, and then we wait for another second, and then because it's void loop, it goes again, and again, and again, and again, and again. So that's basically how it works. I think what we'll do, what you could do just to test if you understand this is try and change this code, and see if you can just, let's start off with, see if you can make it turn on for 2 seconds and then off for 2 seconds. How would you do that? What part of the code would you change? If you want to pause the video, think about that and then play it again when you're ready. Okay, so the part that you need to change is you need to change this thing inside of delay to 2000, and then you need to change this one to 2000 as well. And that will turn it on for 2 seconds and off for 2 seconds. So, this is basically the default code when you start TinkerCad. So I definitely recommend connecting up this circuit and clicking on the code button and having a look at it and seeing if you can play around with it. And do play around with it. The most useful part of this program is that you can learn a lot from playing around and seeing what works and seeing what doesn't work. So I completely forgot to say that despite the fact that this is a virtual, TinkerCad is a virtual circuit and it's not real, you can buy real Arduinos and connect them to real circuits. They're about $30 to $40. And you can also buy this thing called a breadboard, which will help you organize all your wires. So that's how to translate this to real life. And here's the program. Here's the actual program that you use if you buy a real Arduino. And you can see that it's got exactly the same void loop, exactly the same void setup. All of the code will be the same as TinkerCad, which is why TinkerCad is so good, because you can model your code in TinkerCad and then apply it to the real world. There are some, you can't just go straight away from TinkerCad to the real world, because you do need to realize the Arduino can break, basically. And TinkerCad's not a perfect model either. So you need to actually know how much the voltage of all the sections and how to power the Arduino. So there's tutorials on that. But yeah, that's how to connect it to the real world.